All right, everybody, so we are looking at the first lesson in Unit 4, and it's section 5.4. There's nothing special about why Unit 4 starts with textbook section 5.4. We just decided to split up all of the trigonometry, which is actually, I believe, 3 chapters. We've split it up partway through chapter 5. So we're going to be looking at trigonometric equations today, but we're going to be solving them graphically. And it's important, I think, for you to understand we're solving these equations graphically because sometimes it's just easier to do so. But we're also solving them graphically because at this level, sometimes the equations cannot be solved algebraically. They can be solved algebraically, but not by us at this level. So there's a variety of reasons why we need to know how to solve equations that are trigonometric graphically. And then we're going to be looking at applications of sine and cosine functions. To begin with here, a bit of a review. I give you the equation 4 cos squared of x minus 3 equals 0 with a domain of 0 to 360 degrees. We want to solve it algebraically. So what does that mean algebraically? It means to use symbolic language in mathematics, x's and cosine and numbers and equations and rules, to solve it on paper. And I say that because sometimes on an exam or an assignment, you are asked to do something algebraically, and people think the word algebraically just means using math. And they think that they're allowed to do it on their graphing calculator. That's not algebraic. So the first thing you might have noticed is I changed x to theta. I did that so that those few of you who might be a little confused by x in the equation can think of a rotation angle. This is a case where we have a quadratic term and we have a constant term. So to solve this, we isolate the quadratic term. And then isolate the trigonometric portion of the quadratic term by dividing by 4 to get cos squared of theta equals 3/4. Then we finally isolate the trigonometric function, which is cos of theta, by taking plus or minus the square root. And we get cos of theta equals plus or minus root 3 over 2. And although you could certainly solve this by talking about reference angles and quadrants, I think it's more to the point here at this level that you can solve it by using the unit circle. If you want to find a reference angle for both of these equations, feel free. The reference angle is going to be, I believe, 60 degrees. So you're going to be looking at, for the first equation where cosine is positive, a 60-degree reference angle in quadrant 1 and 4. And for the second equation where cosine is negative, you're going to be looking at a 60-degree reference angle in quadrants 2 and 3. However, I would prefer just to look at the unit circle, so I'm going to sketch a circle. A little floppy around the top, but that's okay. Cosine, I'll do this using different colors. Cosine of theta equals root 3 over 2. Root 3 over 2 occurs here for x and here for x. On the other hand, we have the other equation, which is cosine of theta equals negative root 3 over 2. For x, we're looking at x coordinates here because it's cosine. These are the two places where the x coordinate is negative root 3 over 2. So what we have are the following terminal arms. We have that terminal arm, this terminal arm. I don't know how well I've drawn this. These should be directly in line with each other. That terminal arm and this terminal arm. And now we start writing down what the solutions are. Remember, solutions are rotation angles. So we have this rotation angle, we have this rotation angle, this one, and that one. So we have 4 rotation angles to figure out. You can see that I screwed up, didn't I? Well, no, I didn't screw up. What is the reference angle? Go ahead and take inverse cos of root 3 over 2. And you can type in somebody how many degrees you get for a reference angle. 30. So I screwed up verbally because a little while ago I said, you know, feel free to use a reference angle approach, and I was talking about these equations in the bottom right of your screen. I said, I believe you'll get a reference angle of 60. The reference angle is actually 30. So for the first equation, it would be 30 degrees in quadrants 1 and 4. In the second, it would be 30 degrees in quadrants 2 and 3. So I just misspoke when I said 60 degrees. So when we can calculate these angles, one of them will be 30 degrees, one will be 150, one will be 210, and one will be 330. So I want to make sure that everybody is able to get those rotation angles. Theta here is going to be 30 degrees and 330 degrees. Theta over here is going to be 150 degrees. And what I believe is 210 degrees. So I'm just going to ask a couple of you to verify via the chat that those are the numbers we get. 30, 150, 210, and 330. Colton says yes. Anybody else? Aaron, looks good. Keith, yes. Dan, yeah. Lauren, good. I think we're okay. So those are the solutions. Now, how could we solve this graphically? Well, you know that you can solve any equation graphically. Let me write down the equation here again. The equation is 4 cosine squared of x is minus 3 is equal to 0. So how can we solve this graphically? One of the things we could do is we could graph y1 equals this, and then look at the x-intercepts. This is one of the methods you could use. You don't have to do it this way. Let's see what happens here. This is your first foray into graphing trigonometric functions. Just give me a second, please. Nope, we're fine. This is your first foray into graphing trigonometric functions, so you need to follow the directions very carefully here. We're going to go y equals 4 cos x n bracket squared. Now, that may look like it's only squaring x, but it's squaring cosine. So when you enter cos squared of x on your calculator, that's how you enter it. If you were to put that x or that squared in brackets with the x, that would be wrong. Then it would only be squaring the x. And then minus 3. And we want to be in the mode of the unit that we're solving for. So we want to be in degrees, because this question wants answers in degrees. And then this is very important. Until you learn otherwise, go zoom trig, zoom 7. That will change a little bit later today, but zoom trig is the way to go. So we put the calculator in degree mode because we want answers in degrees, and now what we are after, everybody, are the x-intercepts, because the x-intercepts are where y equals 0. That means we need to identify this point, this point, this point, and this point. Well, I hope it's going to be no surprise that they will be 30 degrees, 150, 210, and 330. To find them, we go to our Calculate menu and choose 0. Move close to, but to the left of one of the X-intercepts and hit Enter, and then move close to, but past the X-intercept to the right and hit Enter a couple more times. You get 30 degrees. So I'm not going to do this with all of them. You get 30 degrees, okay? You'll get 150 for the next, 210 for the next, 330 for the last one. I prefer, it's just a preference, I prefer to graph x, theta, I don't care. I prefer to move the 3 over and graph y1 equals 4 cos squared and y2 equals 3 for the sole reason that for me anyway, it's simpler on a calculator to find intersection points rather than x-intercepts. What this is going to look like is we will not have the -3 here. We're going to have +3 for y2. Again, zoom 7, but I'm already in that zoom setting. I don't care about x-intercepts. What I care about is intersection points. And to find an intersection point, I don't have to worry about left or right. All I have to do is choose intersect, go close to the intersection point that I'm interested in, and hit Enter 3 times. I don't have to move the cursor left, right, or anything. And I get 30 degrees. There is another, no, I'll save that for later. So, does anybody have any questions on either the algebraic approach to solving this equation or the graphical approach? This is certainly one that I would hope you could solve algebraically. Now, let's take a look at the next question. The next question says solve this equation. But since the argument in the trigonometric function, the argument is the thing that you operate on. I've mentioned this before, but we've been out of the classroom for a while. In root 2x, 2x is the argument. In 4x minus 3 to the 12, 4x minus 3 is the argument. So in sine of 2x minus 7, 2x minus 7 is the argument. It's just a terminology thing. And what I want to tell you is that when the argument is anything other than x or theta or b or a, you cannot solve them algebraically. If you try to solve this equation algebraically, you'll go a little bit loopy. You'll get to a point where something will not make sense. And the reason is there's no angles involved here. This has nothing to do with angles or quadrants on the unit circle. It's just an equation. So we're going to solve it graphically. We are going to graph y1 equals 10 and y2 equals 6 sine of 2x minus 7 plus 8. But because of all of the transformations that have occurred here, there's a vertical stretch by a factor of 6. There's a shift of 8 units up. There's a change to the period because of that 2 in front of x. Because of all that, zoom trig does not work. What you want to do from here on in when you graph these is manually adjust your window settings. The basic idea here, everybody, is the following. If you graph a sine function over one period, then basically it looks something like this. Basically, all right? And if you want to see that on your graphing calculator screen, then you need to set the minimum x equal to 0, the maximum x equal to whatever the period is. If you don't manually change those settings, you won't see it. The other thing you want to make sure that you include is the maximum and minimum y. There is a y min. There is a y max. And if we can identify the minimum and maximum y on the function, the minimum and maximum x on the function, then we can graph it and see it. So looking at this, I would like everybody to figure out for this function, and this is related to what we did yesterday, what the maximum value of the function is and what the minimum value of the function is. And if you do figure them out, I would like to know who figures them out, please, so you can type your answers in chat. Another way that I can ask this question is if you graphed y equals that function, what would the range of that function be? Sarah says 2 and 14. Jenna says 2 and 14. They're both right. Sarah, can you tell me how you got 14?
Well, I knew that the original would be -1 to 1.
Yep.
So I did the vertical stretch of a factor of 6.
Yep.
And then I added 8 onto both of those.
Okay, so what Sarah did was she said, thank you, Sarah, that normally sine or cosine has a maximum of 1 and a minimum of -1. But this gets stretched vertically by a factor of 6, which means this maximum becomes 6 and the minimum becomes -6. And then she jacked all these up by adding 8 to them. And you end up with 2 and 14. Jenna, you got 2 and 14 as well. Did you use the exact same line of thinking?
Yes, I did.
Oh, you did. See, what I would do, there's nothing wrong with that thinking. Nothing wrong at all with that thinking. But what I would do is the following kind of in my head. I would say that the middle of a sine or cosine graph is normally here, and the graph goes the amplitude above and the amplitude below. Emily checked her table out on the calculator to find it. What I would do is I would say that's where the middle of the graph is on the x-axis. But the graph is shifted up 8 units. So the middle of the graph is the vertical displacement. The vertical displacement is 8. If A is 6, then what that tells us is that the graph goes 6 below it and 6 above it. Now we get the same things, but to me, and this isn't a criticism of any other way to do it, but to me it makes more sense to talk about where the middle is and then adding 6 to the middle and taking 6 away from the middle. And I'm trying to help you out for your next assignment, by the way. If we add 6 because the amplitude is 6, this takes us to 14. If we subtract 6 because the amplitude is 6, this takes us to 2. So getting back now to our question, we know that if we want to see the graph, we're going to have to take these numbers into account. Now I also want to take a look at one period of the graph. Sorry, it's not 8, it's 14, isn't it? We want to take a look at one period of the graph, and the period is 2 pi over b. So the period is 2 pi over 2. which means the period of this graph is pi. So we're going to be looking from 0 up to pi. Okay, let's go to our calculator now. I'm going to enter in the function. For y1, we can put the number 10. For y2, we can put the function 6 multiplied by sine of 2x minus 7, n bracket, plus 8. Now, what's about to happen here is something that will happen to all of you at some point in time. Most of you anyway. Let's set our window settings up. We said that for x we wanted to go from 0 to pi. And this x scale is just where they're going to put the ticks. And for y, we don't want to start at 2, and we don't want to end at 14. We want to go from, say, 0 maybe to 16, up by chunks of 2. So if you're following along, you've done everything I've told you to do, and yet when you go graph, you see a straight line. And then you see, well, that's the 10, and then you see that other graph, and that other graph is supposed to look like this. What have I done wrong? And it's what have you done wrong? Because you've typed everything in exactly the same way I have. You have the same functions. You have the same window settings. Does anybody know what we didn't do here that we need to do? Exactly. I'm in the wrong mode. And for this question, it doesn't say what mode we should be in, but there's no degree symbol on this. This thing has no degree symbol. If it was a question that wanted answers in degrees, then we would have seen a degree symbol there. And it's really hard for students to understand why it should make a difference, but it does. Those of you that take calculus next semester in quarter 4 will discover there are some mathematical processes that if you use degrees, you just don't get the right answers anyway. It doesn't matter which way you think, you have to be in radians. So we have to make sure that we are in radians. And now here comes y equals 10. There's a beautiful trigonometric function coming up, and we want to solve this equation. Now, it isn't as easy as just finding the intersection points. I hope that you remember when we found general solutions to trig equations, we found the solutions for one rotation, and then we added multiples of 2 pi, always. Well, here, we're not going to be adding multiples of 2 pi, and I will show you why in a second. But let's find those solutions first. So I'm going to go to my calculate menu and choose intersect. And I'll scroll over to the left-hand intersection point first and hit enter 3 times and get 0.5283 radians. And then I'm going to go to the other one. And get 1.76. So we have a solution here. In fact, you know what? We have a solution of 1.76 rads. And we have a solution of 0.53 rads. Now we're asked for a general solution over all real numbers. Will this line and this curve intersect anywhere else? Well, of course they will, because the curve goes on forever and ever in both directions. So the reality of it is that they are going to intersect somewhere else, but not at 0.53 and 1.76. They're going to intersect somewhere else, but not at 0.3 and 1.76. Anybody know how we can find out where this intersection point is? Without changing our window settings and finding it? I'm really waiting this out because it's a tough question. Nobody wants to take a stab at it? Yeah, it is going to be pi plus 0.53. This will be pi plus 0.53. This one will be pi plus 1.76. Why are we adding pi, Aidan? Ah, I love it. Each window is pi long, and the reason each window is pi long is because the period of the graph is pi. See, normally you say plus multiples of 2 pi, because normally the function is sine of x, which has a period of 2 pi. We haven't really talked about it that way, but normally we say plus multiples of 2 pi because a full revolution takes us back to where it starts again. Here it's not a full revolution, it turns out it's half a revolution. So the general solution here, our answer is going to be x is equal to, or theta or whatever it was, 0.53 plus multiples of pi and 1.76 plus multiples of pi, where n is, of course, an integer. And if the period of the function were pi over 6, for some reason, then we would add multiples of pi over 6, because that's how long it would take to repeat. And this is precisely why I ask for your windows to be pi long. If this is pi, if that's pi, then this is pi. Bad color. If that red distance is pi, then the distance between those two intersection points will be pi as well. So any questions with that example? All right, let's take a look at the next one. And now we're dealing with applications. There are many things in nature that when you plot them on a graph, they give us a cosine or a sine curve. I'm not going to put the y-axis on this function, but this question says the depth of water in a harbor can be represented by a trigonometric function where the vertical axis is the depth of water and the horizontal axis is the time. We'll get to how the time is measured in a second, but why on earth should the depth of water in a harbor oscillate up and down over time? The answer is that tides come in and out, and when the tide comes in, the water in the harbor rises. When the tide goes out, the water goes down. You can look online at pictures of harbors at low tide, and all the boats are just sitting on dirt and sand because all of the water has been pulled out. And then at high tide, they're quite high up. So the level of water, and some of you know this and some of you don't, the level of water in a harbor goes up and down regularly. And it turns out that that is the equation that describes it. Listen very carefully. To solve any application problem, you never do it algebraically. You want to do this graphically. So the first thing we need to do is plot this graph for one period. It's always for one period. I'm going to give everybody a couple of minutes here because I would like you to figure out what we should put for x min. Well, x min will always be 0. For x max, for y min, and y max. I'm interested in knowing what the maximum and minimum values of that function are, as well as what the maximum x should be so that we see one period. I suspect most of you will get the max min y's first. So if you get the max min y's and you think that they are 1 and 7, which they are not, okay, then you can type into chat the following. You can tell me that the range of this function is 1 to 7 by typing this. Of course, that's wrong, right? It's not 1 to 7. But I'm asking for you to type it in using that format if you figure it out. Chloe's got it, Aiden's got it. So Chloe, I'll ask you first. This is just my way of thinking. And if you, Dan's got it, and Chloe, if you did a different thing in your brain, that's fine, I'm just curious. My way of thinking is to say that the 18.5 tells me the middle of the graph is at 18.5. So the middle is that y equals 18.5. When I look at this graph, I see that little a is -8, which means the amplitude is 8. So my way of thinking is I add 8 to 18.5 to get to the top, and I subtract 8 from 18.5 to get to the bottom. Is that how you thought of it, Chloe? Okay, and perfect. And there are other people that will do what Sarah did, and somebody else, I can't remember, it doesn't matter. What Sarah did, where I believe she did the stretch first and then shifted it. But in either case, this is going to be at 8 less than 18.5. This will be at 8 more, which gives us the idea that we want to go for up to at least 26.5, which means probably even more, maybe 30. So now we know those numbers. 10.5, 18.5. Has anybody got X max, which, by the way, is the period? $12. Excellent. It is 12. And correct me if I'm wrong, Aiden, but what you said is Mr. Way told us the period is 2 pi over b, and I can see that b is pi over 6. So we have k equals, the period equals 2 pi over pi over 6. And how I would simplify this, you know what, I better not skimp on this explanation. We have to simplify this. There's two ways we can do it. The way I like to do this is I like to multiply the top and the bottom of this fraction by 6 so that these 6's cancel, the pi's cancel, and you get 12. However, many of you will have been taught that when you're dividing by a fraction, you multiply by the reciprocal, so the pi's cancel and you get 12. By typing in chat, how many of you would do A in the future, and how many of you would do B in the future? Okay, I'm glad most of you are saying A. If you're doing B, that's fine. I don't want to dissuade you from doing that. But A, as a tool, this is a more utilitarian tool, which means you can use it in a lot of situations. You can only flip this over and multiply in B if it's a single fraction. So A is, maybe it looks messier, but that's what we have to do. So now, getting back to this, we're going to go from 0 to 12. Let's go ahead and graph this. All of the work is done. Once we graph it, we can answer the question. All right. So y equals -8 cosine. Now, I don't like to go pi over 6 times x. I prefer to go pi x over 6. It doesn't matter. I just like the look of it better, okay? And then we close brackets on the cosine and add 18.5. Are we in radians? Yep. We set up our window settings and go from 0 to 12. Now, by the way, t is hours, and the reason why the period is 12 hours is tides go in and out every 12 hours. They repeat every 12 hours. And for y, we go 0. I like to start at 0. We're going to go up to at least 18.5, so I'll go up to 20. If we've done our job right, we should see a smooth kind of curve. And I made a mistake. I wrote 18.5. I believe I should have written, can you help me out? Was it 26.5? Okay. So I'm going to go back and change my y max to 26.5. Well, we'll go 28. While that's graphing, I'll fix my error over here. Okay, so now let's answer the questions. What is the first question? Find the depth at 250. So I need you to understand for question A that when you're asked for the time at 250, you're given the time, and you want to find y. This is kind of important. Time is x. And if you're given the time, all you have to do to answer the question is put the time in once you go trace. So if you hit your trace key, if I can get it erased, if you hit your trace key, you can just enter the time. So if I enter 5 hours after midnight, the depth is 25.42. I would like everybody to figure out, please, and you can write your answer in chat, what this is as a decimal number of hours. 2 hours and 50 minutes after midnight, 2:50 in the morning. It's not 2.5 hours. Can we just get it in a decimal? And Colton, does the 3 repeat? Pretty sure. And Aiden, I'm pretty sure when you take 17 divided by 6, you get 2.83 repeating. The idea here is that there are 60 minutes in an hour, so you take 2 hours plus 50 over 60, which is 2.83 repeating, which is 17 over 6. But for these questions, we tend to just like to use decimals. So all I do is I enter now go trace, .83333. By the way, you could go trace and enter 17 over 6. The answer to the question is 17.8 meters. Are we okay with question A? And does anybody have any questions with A? All right, now B is different than A. Obviously, it's a different question. But in B, you are given a y and asked to find the x. And unfortunately, there's no way for you to, on your TI calculator, put in a y and get it to spit out an x. What we do instead is we plot a second y. When is the depth at 25 meters? Well, let's plot 25 meters and find out when that happens. And of course, since the water goes up and down, it's going to happen a couple of times every cycle. But the question said, when does it first reach 25 meters? So it first reaches 25 meters at this time. Whatever that time is, that's the answer to question B. So we just need to find the point of intersection. So you go to your calculate menu, choose intersect. Because there are different intersection points, you maybe can't see it, but my cursor is closer to the one on the left. When I hit enter 3 times, I get 4.8 hours after midnight. It's not necessary for you to convert that back into hours and minutes. The next question is, what percentage of the time is the water above 20 meters? So again, 20 is a y. We have to graph that to understand what this question is talking about. So for C, we want to determine the 2 times that the water is at 20 meters so we can find out what length of time it's above 20 meters. I'm going to give everybody a minute here to calculate those two times using the intersection feature of your calculator. And when you put them into chat so I can see your progress, you can just put the smaller, comma, the bigger. I'll give you a minute to do so. It's looking like we're all in agreement here. Well, everybody who's done it so far. So there's my screen capture from my calculator for each of them. So I get, and so does everybody else, 3.36 hours and 8.64 hours. So we need to subtract them to find out what the time is, how many hours the depth is above 20. So I need to take that 8.6397 and subtract 3.36023. That's close enough. Can I get anybody to confirm that it's about 5.27 hours? Okay. But that is only how many hours it's above 20 meters. The question is, what percent of the time is it above 20 meters? So it's 5.27 hours out of how many hours in total? Well, it's 12 hours because we are only looking at a screen width, as Aidan said, that's equal to the period. And the screen width here is 12. We're going from 0 to 12 hours. That means we can calculate the percentage by taking the 5.27 divided by 12 and multiplying by 100 and getting something under 50%. I don't know. Divided by 12 times 100. About 44% of the time. Does anybody have any questions with 3A, B, or C? All right, so we're going to move on. We have to look at one last example. One of the things that students in Math 30-1 are expected to be able to do is to come up with a trigonometric equation that describes something occurring in nature. And that's what example 4 deals with. Example 4 says we have a Ferris wheel at Westworld Theme Park. The diameter of the wheel, and you can see the picture there, is 30 meters. And you're given some other information. It moves around 6 times per minute. And the bottom of the Ferris wheel is 4 meters above the ground. So when we take a look at this picture, in order for it's Joel and Ellie that are going to get on this Ferris wheel. In order for them to get on, they walk up some stairs and then they get in the Ferris wheel here at this point. So this is where Joel and Ellie start. They start at the bottom. Now the Ferris wheel is going to turn, and it doesn't matter which way it turns. Let's just say it turns counterclockwise. It doesn't matter. you'll notice that what I've put here on my diagram, these two brown lines, are axes. What the vertical line is the height of Joel and Ellie. So this is the height in meters. And what I've got along the horizontal axis is time. And the reason I'm setting up my axes that way is the question says, determine an equation relating the height of Joel and Ellie as a function of time in seconds. And it's the height above the ground. So what I have for you now is a series of questions. Joel and Ellie, I can't spin this, but Joel and Ellie are going to move in this direction, and what's going to happen then is they go from having a height here at the beginning of the ride to sometime later having a height maybe here. You're not drawing this, I'm just explaining. And eventually what is going to happen is when they get to the top, they will be at a maximum height, and that maximum height will of course be some point up here, but then as it continues to rotate, what am I doing here? There we go. Joel and Ellie are going to start decreasing the height until they get back to the bottom. The bottom line here, and you're not drawing this, please do not draw it yet because we want a good diagram, is the graph is going to look like this. It's a trigonometric function. It goes up, up, down, down. And our job is to determine the equation of that trigonometric function. So what I need from you is the following. I want everybody to figure out, we'll do this in stages, what the maximum height of Joel and Ellie will be and what the minimum height of Joel and Ellie will be above the ground. And again, I'm looking for answers in Google Chat, please. And if all you're doing is looking at this screen, you will not be able to get the numbers. You need to be aware of something else. And the answers are starting to come in. The maximum is going to be 34 meters, and the minimum is 4 meters. You can see that, I hope, by simply looking at, and I hope you're going to appreciate what I'm about to draw, by simply looking at the fact that this is their lowest point and this is their highest point. And I hope you can see that this is the middle of the ride. And half of the time they're going to be above that middle line, and half of the time they will be below that middle line. Now I have something else that I need to ask you. Well, I don't need to, but I want to ask you some more questions. We know the maximum and minimum heights. That's great. I want you to figure out now what the amplitude of the periodic function, of the trig function, is going to be. And I also want you to figure out what the vertical displacement of the trigonometric function is going to be. And you can communicate your answers by saying capital A equals and lowercase d equals. And it occurs to me that I did a pretty crappy job in explaining the 34 meters. I just drew that horizontal line. The reason why it's 34 is the diameter of this wheel is 30 meters. right? This distance, you're told, is 30 meters, which means half of the distance is 15, and that's why the amplitude is 15. The amplitude is the distance from the middle to the top. So if the wheel is 30 tall, this distance is 15, this distance is 15, the amplitude is 15. And if the amplitude is 15, to get the vertical displacement, you can take 4 at the bottom and add 15 to get 19. Or you could take 34 at the top and take away 15 to get 19. So, by the way, what capital A equals 15 means is A equals 15. Now, take a look at the question, please. Does the question care whether we use sine or cosine? Or does it just say determine an equation? Well, it says determine an equation. Since, we're going to be smart about this, since Joel and Ellie start at the bottom and move up, I'm going to use cosine. But I'm going to use negative 15 as A. And the reason for that is really important. If I use negative 15 and I use a cosine graph, cosine normally starts at the top going down. So if I have a negative A, cosine will start at the bottom going up. And that means I don't have to fiddle around and try to find C. It's starting where they start. I don't have to shift to make it work. If we ended up using positive 15, then you would have to figure out how to shift this graph to make it fit this graph. And I'm not saying that's impossible, but why do it unless you have to? So let that sink in. We're using negative 15 to avoid a C. The only other thing we're missing is B. But B is 2 pi over the period. So we're not done yet. There's one more thing you have to figure out for me, and that's what the period of this graph is. What is the period? What is the period of time over which this thing is going to repeat? Up, up, down, down. What is the period? You got it, Sarah. It's 10 seconds. It goes around once every minute. Now, we got to be consistent with the units here, because the question is, the time is in seconds. I'm sorry, it doesn't go around once in a minute. It goes around 6 times in a minute, correct? Yeah. It goes around 6 times, 6 revs every minute, which is 60 seconds. So it goes around 6 times in 60 seconds. It will go around once every 10 seconds, which means that the period is 10 seconds. This is why we use the word period. The period is the period of time it takes to go around once. So what we can do now is find out what B is. B is 2 pi over the period, which is 10. That simplifies to pi over 5. So we are going to take A equals negative 15, D equals 19, and B equals pi over 5, and put them into our equation. I suppose we can use C equals 0 too. Our equation would be y equals a cos b bracket t minus c n bracket plus d. So we will get y equals negative 15 cos pi over 5t plus 19. And that's it for the lesson. The main gist of this lesson is you can solve trigonometric equations graphically, and when it comes to applications, you must solve them graphically. And then you have to be able to come up with the equation to describe certain things. And again, you're going to have an assignment. I think I'll have it ready by Friday. You'll have an assignment dealing with these types of graphs and applications coming up shortly. So there's only about 15 minutes left, but hey, it's Math 30-1. Sometimes you got to spend the time learning the concepts before you can get practice. So these are all textbook questions by solving trig equations graphically and doing applications of sine and cosine. Again, class officially ends at 2:30, but I'm always here till 3. If you have questions, please interrupt me by unmuting your mic or typing something in chat, and I'd be happy to help you out. Quick check, too fast, too slow, just right.